Hey folks, Darren the Maple Syrup Hunter with Fervent Astronomy, here to talk to you today about the Laowa 10mm f2.8 full frame wide angle lens for pretty much every mirrorless mount out there right now. This is actually remarkable because most of the time that we have a new fancy lens from a third party, some of y'all are left out, but this is not the case. Depending on what camera brand you use, you will get either an autofocus version of this lens with, I believe, 5 aperture blades, or a manual focus, which this is, with considerably more aperture blades. And I know I should know this at this point, but I don't really care because I'm looking at shooting this lens wide open, so hey. So in this case, this is the manual focus version, so it doesn't have any of the fancy electronics, but everything else is the same except for that aperture, as we mentioned. That said, we've got, really nice manual focus ring, manually coupled, of course, nice and damp. It's really a pleasure. A clicked aperture ring. I don't know if you can hear that. It's nice and satisfying. I would say the clicks aren't very strong, so it's easy to kind of like miss and go a little too far. Keep that in mind. And under the 77mm filter thread, we have a tiny, tiny, tiny front element. Tiny. It's teeny. It's tiny. When I saw this lens initially, I was like, there's no way that's full frame. This has to be an APS-C lens or micro four thirds even. But somehow this 10mm lens has this tiny, tiny front element. And if you know about optics and you know about wide angle optics, it doesn't make sense initially. It doesn't compute. Apparently it's some kind of high refractive glass that allows them to use a much smaller element. And that does worry me a little bit. Basically, typically, when you get a bigger front element for a lens with a certain aperture, you have a little bit more freedom with your optical formula design, and you can reduce vignetting, you can reduce corner distortions, that type of stuff. The sacrifice is that you end up having a huge front element. To demonstrate this, this is the Samyang 10mm f3.5. So even though it's a slower lens, like it's got a huge front element. So that leads me to wonder, like, is this just going to be magic with this new front element, this new type of glass, or is it going to be a compromise? We're going to really have to find out. That being said, since this is a manual focus version of this lens, there's not a lot else to talk about. There is a removable hood, which it's a little bit tough to get off, but you can see it does come off. And I mean, you probably never have to actually do that. I don't think that it's going to get in the way. I'm not sure that it's going to cause any vignetting. It's really minimal. On the back end here, we have a decent rubber gasket. It's a little bit clear silicone, it looks like, and that will hopefully keep some extra dust or moisture out of your camera. It's a really nice lens. Physically, it's all metal, as a lot of Laowa lenses are. It's got this little blue detail and kind of a gunmetal blue sort of finish, so it's quite pretty, but can't see any of that in the dark. So the thing that I'm really curious about is how is it actually going to perform? So let's look at that. Hey folks, welcome to Lightroom, where we are taking a look at get the box here, Laowa 10mm f2.8. FF2, I think full frame 2, although I didn't know there was a 1. C&D Dreamer manual focus. Boy, that's quite a mouthful. So as you might have picked up, this is a manual focus lens from Laowa. It's a 10mm f2.8 full frame lens, rectilinear, not a fisheye. Available actually for tons of mounts, at least in the manual version. This one's even applicable to Canon RF mount. And of course there's the Nikon Z, Sony E, everything probably. This is the manual focus version with the more aperture blades. Not really relevant for what I'm doing, but there is a less aperture blades version with autofocus. which is even less relevant for astrophotography. That one, of course, is only available on Sony E mount, probably L mount. I would imagine probably, I think Nikon Z mount. They usually let those small third parties play ball. So yeah, here we are. This is a really wide rectilinear lens. This could be a perfect astrophotography lens. It's very fast as far as other very wide lenses are concerned. We're talking so much wider here than even something like a 14mm lens. Although you can get a 14mm 1.4 versus a 10mm 2.8, you do you. Let's look at this stuff so you can decide what might be right for you. So hilariously, all of the samples I took are tracked. None of the samples I took are untracked because I forgot. Everything here is a 60-second exposure. I'm sorry, it is what it is. But yeah, everything here is 60 seconds taken with the Sony a7R Mark V, 60 megapixel sensor in that camera. All these 60-second shots are tracked with the Fornax Mounts LighTrack II portable star tracker. If you want to learn more about that, head on over to ferventastronomy.com and you can do so. Everything here is at ISO 320 pretty much with the a7R Mark V. That's because this is an ISO invariant camera, and that is its second base ISO. If you want to learn more about that, probably around now sometime, there's a link popping up at the top right-hand corner of the screen until sometime in the future when they change it and take that away or move it. And if you prefer to read, there's a link in the description. We'll bring you back to our website where you can find a link to a very good article on ISO invariance to explain it in detail. While you're there, you will also get a link to these samples where you can pixel peep and do all that stuff. I just ask you to respect my copyright. I did have to buy the lens, go out and shoot, a day before Christmas, pretty much. Actually, no joke, was out until the 24th, around 1 or 2 a.m. So please respect that. Just use these for the purpose of assessing the lens. In this case, because the copy that I have is the manual focus version, there's no metadata and obviously no electronics. So one thing I can't test with this lens is whether or not it suffers from internal infrared light pollution for modified camera use. The safest bet, and probably the best bet overall, would be to just get the manual focus version anyway. Keep that in mind. It's something that's happening more and more these days. I had at least 3 lenses, if not more, come through my hands, 4 lenses that do have an internal IR light source. So it's happening. Right here, this is a focus check. You can see we've got 3 diffraction spikes, and you can actually see the shadow from the Bahtinov mask here. This Bahtinov mask is meant for a telephoto optic, but this did work because I think this was Jupiter. Pretty sure that was Jupiter. Yeah, is that the Pleiades? Yeah, this was Jupiter. So it was still bright enough. You can see we've got perfect focus. There is cloud coming through and some haze, especially on the horizon here. I do apologize. Can't control the weather, and I figure it's better to do what I can than just to wait forever for perfect conditions. Please keep that in mind. I don't think it's going to actually affect things, but thought I'd mention it. This is at F2.8, and it's pretty dark. So we're going to just brighten probably everything up here. All right. Now, the other thing that complicates things here, since there's no metadata and there's only certain major f-stops that have a detente, I did some kind of half stops in between the major ones. So this is F2.8. So at least we know that. So first thing, you can see there is a significant amount of vignetting. This lens has some kind of fancy high refractive optical glass, but the lens element is tiny, and tiny lens elements tend to vignette badly, and this is no exception. We've got a lot of darkening in the corners. Of course, again, mind you, we might have some clouds or haze coming through, but that's not going to actually be affecting that too much. So we can say that it has vignetting. Here, if we pop into the center of the frame, we can see something kind of unsettling. The star shapes are not round. This is astigmatism. That's the center of the frame. That's astigmatism in the center of the frame. So what's astigmatism? Let's see, we can use this as an example. So this is not coma, this is astigmatism. And this is a failure of the lens to focus the light into a point along 2 axes. The long stretched out part here, that's actually tangential astigmatism. And tangential astigmatism will lie along radii that are from the center of the lens to the edges. If we look on this side, we'll see they're pointing to the center of the frame. If we look over here, we'll see it's pointing the other way, but still to the center of the frame. That's tangential astigmatism. The little bits on the side, that's sagittal astigmatism. These little wings, that's sagittal astigmatism. That's the same phenomenon, just on a different axis. And they are independent. You can get one more or less than the other. Usually you'll get both. Sometimes you'll just get one, but they are both a problem, and they do create those fun shapes like this, like almost like a koi swimming through space. This obviously for astrophotography is not ideal because you want stars to be round, not shaped like a fish. And that can cause visual disturbance and sometimes spoil the image for the viewer. That's why I do reviews like this, to uncover stuff like this. Here we have Jupiter, and oof, it's just getting mangled here. One thing that I'm also seeing, in addition to there being astigmatism in the center of the frame, well, let's try and track down where the actual center of the frame is. I'm having a hard time actually finding it, if I'm being honest. There might be no true center. This looks like it could be. We've got tangential astigmatism coming in that way and this way. Yeah, this is supposed to be the center, and just yucky. Sometimes if the lens elements aren't aligned properly, several aren't aligned properly, it can cause this type of issue. And yeah, it's a bummer. It's just a bummer. So I said that's astigmatism and not coma. For the lens's credit, I don't see coma. Coma is when one side of a star, or stars rather, will get fuzzy, and you have all the fuzzy bits pointing towards the outside or the inside all together, and along the same radii from the center to the edges of the frame. And yeah, here I don't see it, but I do see astigmatism everywhere I look, which is a bigger bummer. Coma is named after coma from comets, that little bit of haze and fuzz that forms around a comet, and its technical term is chromatic aberration, but we're not really dealing with that here. We also don't really have any spherical distortion. We do have some chromatic aberration. We're fringing this purple and blue. That's the lens actually having trouble focusing the blue and maybe some red wavelengths into the same part where all the other light's going, so it ends up out of focus and it looks like a fringe. Field curvature, I don't even know how to assess whether that'd be a problem or not. I don't think it matters. There could be field curvature, maybe a little bit. That's when one part of the frame is in focus, and as you go usually towards the edges, it drops out of focus. In this case, it just doesn't seem like a relevant question to ask, but maybe there's a little bit of field curvature as you get towards the edges, a little loss of focus, and rough. So let's just flip through all of these. Yeah, I have brightened them up, so they'll be brighter than they should have been, but all relative to one another. This is F2.8. This is, I believe, halfway between F2.8 and F4. This should be F4. This is halfway between F4 and 5.6, and this is F5.6. So, look in the center, 2.8, F3 point something, and at least the fringing is cleaning up a little bit. It's still not a round star, it's still astigmatism in the center of the frame, but there you go. This, I believe, is F4. This is F4 point something or 5 point something. And this is F5.6. Dare we look in the corners? F2.8. F3 point something. This is F4. Somewhere between F4 and F5.6, about halfway. And this is F5.6. Come here, try and assess distortion, corrections. Remove chromatic aberration. Don't expect that to do anything. Defringe dropper does work. Of course, doesn't get rid of the astigmatism. And I don't know, is there going to be a profile? Okay, out of the available lenses here, we do not have a built-in profile. I'm not sure if one comes with the autofocus version of the lens, which could potentially be built into the lens. But in our case, we can't really do anything with that. So we can try cleaning the vignetting up manually, although we wouldn't have the faintest idea about how to try and assess the distortion. So probably doesn't matter. All right, so obviously I have more samples than that. Here I have a different comp. This is closer to the horizon and wanted to show really bright. We've got Jupiter here in the center of the frame. And yeah, you can see that astigmatism is just dead center in the center of the frame. It's quite strong. We can take a look as we stop down. This is 2.8. I don't even know, but we can start to see immediately nice star tines, right? From those aperture blades. It's gonna drive me crazy. Let's see what the box says. So according to the box, we have 14 aperture blades. All right, we can see as we stop down here, our aperture blades, the 14 aperture blades are causing these diffraction spikes, these tines, which actually do a better job of making the star look round than the actual glass elements do. And you know, as we stop down towards f5.6, it's just so dark. It's not really worth it. It is not the only 10mm lens that I've tested, rectilinear full frame lens. I also have tested the Samyang 10mm f3.5 lens. So let's kind of compare those two real quick and see what we can see with that comparison. Just like magic, we have a bunch of extra samples here. Here we can see that we are in focus with the Bahtinov mask. And so first of all, let's do a really important check. This is f3.5. Oh yeah, look. We don't have weird astigmatism in the center of the lens. Come over here. We do have some astigmatism coming out towards the edge. Not too bad, although it's really, really dark in the periphery here. But yeah, nowhere near what we were seeing with the Laowa lens, although we are at f3.5. So this one's at f2.8, and I believe I squeezed 2 stops in, and then this one's at f4. So this should be 2.8, 3.2, 3.5, f4. So here we have f3.5 with the Laowa, and this is f3.5 with the Samyang. We'll just compare them side by side. Here we have the Laowa lens on the left, Samyang lens on the right. If we zoom in, yeah, we can see already we've got some tines here with the Laowa because of course the aperture blades are coming to play. Not so much with the Samyang, but of course we aren't getting those same warpy astigmatism stars. There's maybe like a little nubbin on some of these, but these are by far more round than these. Come over here, you can see of course different styles of astigmatism. Although I would say that we're getting more exposure in with the Samyang lens than the Laowa. Although in the corner here, I guess junky is still junky. Getting really long tangential astigmatism with the Laowa. Still astigmatism with the Samyang, but not as bad. The top right, Samyang here I think is a clear winner. Less astigmatism. Bottom right, yeah, same thing. Lots of tangential astigmatism with the Laowa. And of course there is some with the Samyang, but not too big a deal. Let's look at Orion here. I would say there's a little bit of field curvature here with the Laowa, a little bit less with the Samyang, although we've got more chromatic aberration with the Samyang and like different kinds of astigmatism causing different shapes. But overall, yeah, I think this is the main difference. So, you know, your mileage may vary. If you prefer the option of going a little bit faster, the Laowa lens is there. If you don't think you'll notice the astigmatism of the stars in the center of the frame, it's not a bad thing then. Although the astigmatism at the edges, you are getting the tangential astigmatism stretching things out lots more here with the Laowa. And this only gets worse as you open the lens up to f2.8. So do with that what you will. As I always say, I am not your mom. I'm not here to make this decision for you. Just giving you the tools to do it. So with that, let's wrap this up. I think this has been a long one. Let's get back to talking head me to see what I have to say about it. So that is the Laowa f2.8 10mm wide angle lens for full frame cameras. And that tiny little front element, it turns out it does unfortunately necessitate some sacrifices. In this case, I'm not sure that they are worthy sacrifices for astrophotography personally, but that's not my choice. That's the choice for you to make. But yeah, it's kind of unfortunate because they did have extra real estate here to incorporate a bigger front element. Maybe some of the little performance glitches there would have been a little bit better, but it's not meant primarily for astrophotography, I guess. That being said, for a lower megapixel camera for untracked work, it might actually be okay. So that's something that you might want to take into account yourselves. In this case, this one, I might wait for version 2 myself, but it is interesting what they are able to actually do these days. At any rate, I'm Darren. This has been Fervent Astronomy. Hopefully we'll see you in the next one. If you found this review useful or just worth your time, I hate to do the YouTube stuff, but it does apparently help get these videos seen if you use the like button there If you really hated it, by all means, hit the thumbs down. In either case, I would love it if you'd want to comment. I love to chat. Getting messages from viewers is something I really enjoy. I love responding. So if you have questions, please, by all means, ask them. At any rate, hopefully we'll see you in the next one.